Hi everyone, hello to Summon. This is Kevin Moreno. I am gonna record a video to show you a short tutorial how to perform the 3D point cloud and operate it in Rhino. This tutorial is for the course Forest Architecture Shape in the Forest, teaching the summer semester at the RWTH Hague University. In this case, the 3D model that you are going to produce is simplified by cylinders, but also we got an approximation with NURBS that sometimes is working, and what is also important is to get the center line of the tree, so the growth direction. We also prepared a checklist following the workshop that we prepared yesterday. The first step will be to get a point cloud. We are going to use Luma AI. Afterwards, we will modify the point cloud in the software Cloud Compare, and later we will prepare the information in Rhino. For this seminar, we are going to use the platform Luma AI, but you can also use other, for example, Polycam, where you can create 3D models of trees. The first step is going to be to create a model. You can do this uploading photos to the platform. For example, you can take photos of your tree and create a new 3D model, dropping the files here, or you can download the app into your phone. When you have your tree, you just need to download the file. For downloading the file, you just have to click here on the top right, and then you need to download the scene, and we click here in Point Cloud. So the first step is going to be to import our point cloud to Cloud Compare. We just simply drag it to Cloud Compare. We click to apply all, and after a few seconds we should have the point cloud open in Cloud Compare. As you can see, we have many information that we don't really need, so we are going to follow several steps to prepare the model. We attach to the checklist, we are going to start leveling the model, then we are going to perform a scale operation, then we are going to eliminate the points. Afterward, we can convert the points to a mesh and export the file to open in Rhino. So the first step is going to be to level our model. We have to click always to the file that we want to modify, and then we go to Tools, Level, and here in this part it's going to give us some information. So it's asking us to select 3 points on the floor. In this case, I'm going to click 3 different points, and we have our tree level. The next step is going to be to scale the model. As we informed you, you should have placed some markers into the tree. If we orbit a little bit and move, we can see the 2 markers. So these 2 markers will have a distance of 1 meter. Now we can choose 2 points to scale the model. We can go to Tools, Point Picking. We select 2 points. Now we have to divide 1 meter through this distance, and we can scale our model. We select our point cloud, edit, multiply scale, and we perform a scale of 2.08. In the next step, we are going to remove all the information that we don't need. Therefore, we click into the cross-section tool and we start to move the arrows of the bounding box. Now we have to be sure that we don't remove any part of the tree that we might need. After, we click to export the selection as a new entity. We can close, and now we have a new point cloud with the information that we need. In the next phase, if we have still some information that we don't need, we can use the tool segment, and now we can draw a polyline and select all the points that we don't need. We click on the right click, and now we can click to segment out the points. And click to eliminate. In case that we have some information that is difficult to get out, for example the leaves of the tree, we can for example select the colors, select the points that share a common color. In that case we should generate an scalar field. To do this, we go to Edit, Colors, Convert to Scalar Field. We can convert the colors RGB, and now if we had some greens, for example, they will have a different color, such as red. In this section of the software, we can scroll down and we can pick out colors, for example, that we don't need using this graph. In this case, it's not relevant, but in case that you want to remove points, you can go to Edit, Scalar Field, and Filter by Value. Now we can export new entities, and we have a bit more clean. You can go back to the original colors just simply clicking here. From now you can just export your 3D model, but we want to perform a mesh. Here on the right panel you have some plugins that come directly with the Cloud Compare, and this one, Poisson Surface Reconstruction, is what we need. It's going to ask always to have normals. To generate the normals, you just go to Edit, Normals, Compute Normals. The software is going to try to find the direction of the normals automatically. Now you might see a different color. That means that dark or black is in the outside, and inside you are gonna see the real color of the tree. That means that the normals are flipped. So we can go to Edit, Normals, Invert. Now we have our normals prepared, so we can prepare a mesh. In the surface reconstruction, we can increment this number, but I don't suggest you to go more than 10. What is also important is to output the density field. So we click here, and in a couple of seconds the software is going to generate the mesh. What you see here is a bit funny, but you can get rid of it exactly as we did before, selecting the different colors of the scalar field. So you can just scroll these sliders and you can filter the parts that you don't need. In this case, the mesh is not detailed enough, so we can make another iteration. And now we are going to try to increment up to 10. Okay, it took approximately 20 seconds. Now we can perform the filter again. We go back here and we move the slider to filter out the information that we don't need. We go to Edit, Scalar Fill, Filter by Value, and Export. We can eliminate the last one, and we can show the original colors again. Now we have a quite detailed mesh of our tree. In this software you can also simplify the mesh or clean it a little bit. Just go to Edit, Mesh, and you can go to Smooth using the Laplacian algorithm. Now we export the point cloud. We go to File, Save. It's important to find the format PLY. We save our file in binary. Additionally, you can export the mesh. In this case, I will suggest you to use the format OBJ, but you can also use STL or FBX, but then you are gonna get rid of the colors. Now we can open our mesh and point cloud in Rhino. If you just drop the files here, it should look something like this. We have our point cloud and our mesh. This point cloud needs to be exported again so we can process our 3D model. We just select our point cloud and we go to File, Export Selected, and we export our file into the format txt. We need to leave it as it is, so it's important to delimiter the points with a comma. And let's take a look. Now the file is exported like this. You just need to wait a little bit until we process your file, and afterwards you are going to get that one. In this file, we sort the information into radius, length, start point, X direction, and this information is necessary to build the 3D model of the tree. So in the next step, you just need to open Grasshopper, open the file tree process generator, and here you just need to go to this component and you just need to select one existing file. You go to the tree structure file that we prepare for you. And now Grasshopper created the 3D model of your tree. Here it is important to see these different parts of the file. First we are going to hide our point cloud, but we also prepare this filter so you can select more or less cylinders that compose the tree depending on the radius of the branches. Next step will be to bake this component, but now I'm going to hide it and look at what we have here. Then we can take a look what we get here. That is the tree as a cylinder. And here you can get a Norse model of the tree. So let's hide this part, and you can see that sometimes it's performing better depending on the information of the point cloud. You can bake this component, and also you can take a look of the center curves and bake them. And now when you are finished, you just need to upload the file of your tree into Moodle.